Hey guys, this is Miss Avellán. Today we're going to see how to solve equations. This is one of the worksheets that I sent to you, slithering speeds to magic squares. So I'm going to show you how to solve it. The first thing you need to do is you need to read. Everyone will read like a sentence. So here it says lizard 1 took 3 seconds to travel 12 meters. And then you have to figure out the speed of lizard 1. So you solve it like a sentence here. Remember, speed equals distance over time. So you would take the distance is 12 meters and you would divide it by 3 seconds. That will give you meters per second. So in this case it will be 12 divided by 3. It will be 4 meters per second, and that is the speed of lizard 1. Here you can see all the solutions, and here you can see the square. The square has all of the solutions. The solution for 1, solution for 4, solution for 2. The magic number will be the number that is repeated, meaning adding up all of these squares will give you 15. And in another direction will also give you 15. Another direction will also give you 15. So that's the magic number, the ones that repeated in all of the squares as you add them up horizontally or diagonally. The lizard with the highest speed was lizard 5. Covered 15 meters in 3 seconds for a speed of 5 meters per second. In this worksheet of speed machines, it's the same. You gotta find the speed. The first question says, NASCAR fans love race day when they get a chance to cheer on their favorite team. If a driver was able to travel 600 miles in 3 hours, what was his average speed? If speed equals distance over time, it will be 600 miles divided by 3 hours, and his average speed would be 200 miles per hour. I'm going to show you the answers of all of these ones, the first ones. Notice that this last one, the 5, you have to do it how far it could travel or the distance in 2 hours for time. Then again, you have to do the same for 3 hours and again for 5 hours. Here are the solutions. This is the first solution, the second, the third, the fourth, and the fifth solution. For the next one, what you need to do is you gotta fill in the boxes and use a calculator to determine how long it would take each machine to travel 60 miles. So you already got the speeds of each one of them that you calculated in before. So if we have the speed of the first one, what we want to do is we want to place that speed right here, and then it would be 60 divided by that speed, because remember, from the triangle of speed equals distance over time, if you want to find time, what you do is you divide distance by speed. And so that will give you an answer, but this answer is in hours. So you multiply that by 60 to get the amount of minutes. Here are the answers to those questions. This is the other worksheet. Here we see it's about distance time graph. Here's an explanation of how distance time graph works, and they ask you to match each of the following. Here the car stopped. Here the car is traveling at constant speed, and here actually it is accelerating. So graph 1 will match description B. Graph 3 will match description C because the speed of the car is actually increasing. Here you need to match the part of the graph to the description. This is the second worksheet about graphing speed, and this that you have over here is super useful. I advise you to copy it in your notebook because it will help you every single time. We can see that the faster it's going, the least time it takes, the higher the slope will be. Well, if the slope remains like with a curve, it means that it's getting faster, but it's more constant. Here we can see that it stopped, and here that it's returning to the beginning. Let's interpret this graph of Albert, Bob, and Charlie. What does the slope of each line on the graph tell you? Well, the velocities and how each of them did throughout the race. Which runner completed the 100-meter race in the least amount of time? Albert. His time is right here, 12 seconds. The next question says which runner started out the fastest. You can see again Albert started out the fastest. And what was Charlie doing between 8 and 10.5 seconds? Charlie was doing nothing. He stopped for some reason. What does a straight line on the graph tell you? A straight line tells you that the person is not moving. A curved line tells you that it's moving forward and constantly. At what distance did Albert overtake Bob? Well, this depends. It's subject to interpretation. Some would say around 1 second and perhaps 5 meters. Some would say from the very beginning. On the second part, it says what is happening between 9 and 11. Between 9 and 11, he's covering all these miles at a constant rate. Why do you think bicyclist is doing between 11 and 1? He stopped. Maybe he went for lunch. What was the total distance covered between 11, 1, and 4? 11, 1, and 4, the total distance would be 30 minus 60 would be 30 miles. What was the average speed of the bicyclist between 9 and 11? To find out the average speed, you would have to do the total number of miles divided by the total amount of time. Remember, you cannot ignore that the bicyclist stopped over here. So you'd have to calculate the speed from here to here, which would be 2 hours and 30 miles. So 30 divided by 2 will be 15. And the second one would be 30 miles divided by 3 hours, which would be 10. So 15 plus 10 will give you 25 as the average speed of the bicyclist. Last question says, is the speed a positive or negative number? Could speed ever be a negative number? Speed is a positive number. Speed is a positive number. Could speed ever be a negative number? No, not speed. Acceleration, which we will study next, can be a negative number. This is the end of the worksheets that we've done. I hope if you have any questions, you let me know and that you'll all get 100.